What kind of galaxy is already old before the universe is even old enough to raise one? James Webb is looking into cosmic baby pictures and finding faces that seem fully grown. The first stars are only just switching on, yet whole islands of light are already there. Somehow the universe is moving faster than its own story says it should. And if real space mysteries are your thing, subscribe now before the next clue slips past. We follow the strange facts, the real data, and the moments when science has to stop and rethink. Stay with me because this story does not get smaller the deeper you go. For a long time, astronomers thought they had a simple picture of the early universe. The Big Bang happens, space expands, matter cools, and then slowly, the first stars begin to light up the dark. After that, small galaxies form first, and much later, those small galaxies crash together and grow into bigger ones. That is the basic story. It is not random. And it comes from years of math, computer models, and older telescope data that all seem to point in the same direction. In that picture, the first few 100 million years after the Big Bang are not supposed to be crowded with giant bright systems. They are supposed to be messy, dim, and young. That matters because the universe is old now, about 13.8 billion years old. When we look far out into space, we are also looking back in time because light takes time to travel. So when a telescope sees a galaxy so far away that its light has been traveling for more than 13 billion years, it is showing us what that galaxy looked like near the beginning. In other words, deep space is not just distance, it is history, it is a record, it is the oldest photo album we have. And until James Webb arrived, those oldest pages were blurry, thin, and full of gaps. Older telescopes did give us hints. The Hubble Space Telescope saw one famous early galaxy called GN-Z11, and that alone was exciting because it seemed to come from just 400 million years after the Big Bang. Even that was pushing the limit of what many people expected, but Hubble was working at the edge of its power. It could tell us something was there, but not nearly enough. It was like seeing one lit window far away in a storm and trying to guess the whole city from that single glow. So scientists waited for a telescope built for this exact job, one that could catch much fainter and much redder light than Hubble ever could, and that telescope is James Webb. Webb does not mostly look in visible light, the kind your eyes use every day. It looks in infrared, which is light stretched to longer wavelengths. Because the universe has been expanding the whole time that ancient light has been crossing space, the light from very distant galaxies gets stretched out and reddened. Astronomers call that redshift, and it is a simple idea with a strange effect. A galaxy that once shined in ultraviolet light, the harsh light from hot young stars, can reach us as infrared light billions of years later. Webb was built to see exactly that kind of stretched ancient signal. So the plan sounded clear. Point Webb at the darkest parts of the sky, let it stare for a long time, find the first weak galaxies just starting to assemble, learn when the first stars turned on, when the first black holes appeared, and when the universe began to clear its early fog of hydrogen gas. Scientists were ready for discovery, of course, but many believed the big picture would stay in place, the names might change, the dates might slide a bit, some details would sharpen, but the general story, baby galaxies first and big mature ones much later, was supposed to survive. Webb was expected to fill in blanks, not redraw the opening chapters, and then the first deep fields came in and people started seeing points of light that looked too bright, too large, and too developed for such an early time. This was not one weird object at the edge of an image. It was a pattern. Survey teams like CEERS and JADES kept reporting more distant galaxy candidates than many models had predicted. Some of them looked so bright that if the brightness came only from stars, they seemed to have built huge numbers of stars far too fast. It was the kind of result that makes scientists sit up straight, not because it proves everything is wrong, but because it raises the most dangerous question in science. What if the assumptions were too simple? Did you expect the baby universe to be dim and quiet only to find it crowded and glowing instead? If that flip still feels hard to believe, hit like and tell me whether you would have guessed the first galaxies were tiny or already huge. And if you want more stories where space refuses to behave, subscribe before the next reveal lands. One of the biggest shocks came from a galaxy with a name only astronomers could love, JADES-GS-Z14-0. The JADES team, which stands for JWST, Advanced Deep Extragalactic Survey, confirmed it in 2024. The light we see from that galaxy was emitted only about 290 million years after the Big Bang. Pause on that number. 290 million years sounds large in human life, but in cosmic time it is almost nothing. If the age of the universe were compressed into one normal year, this galaxy appears in the first week, yet it is not a faint smudge barely hanging on at the edge of detection. It is bright enough to stand out, and that is where the tension begins. Now here is the part people remember. JADES-GS-Z14-0 is not just distant, it is also big for its age. Webb measured it at more than 1,600 light years across. That does not make it big compared with the Milky Way, which stretches about 100,000 light years wide, but it makes it surprisingly developed for a system from such an early time. The research team also said its light seemed to come from young stars spread across the galaxy, not mainly from gas falling into one supermassive black hole like a quasar. A quasar is an extremely bright core powered by a black hole feeding fast. If that had been the answer, the brightness would have been easier to explain away. But the size suggested real starlight across the galaxy itself. Why is that such a problem? Because stars do not simply appear because we want them to. Gas has to fall together, gravity has to pull it into dark matter halos, which are the invisible clumps that help galaxies grow. Then gas has to cool, collapse, and form stars. Then enough stars have to form to make the galaxy shine strongly across space. All of that takes time. The older model did allow early galaxies, but mostly smaller, weaker ones. JADES-GS-Z14-0 looks more like a place already deep into the business of making stars. It is not a newborn crying in the dark. It looks more like a small town with lights already on and many windows. And it was not alone. The same JADES work confirmed another galaxy, JADES-GS-Z14-1, almost as far away. Other web programs kept finding candidates from similar ages. Scientists started using phrases like unexpectedly luminous, meaning brighter than expected, and unexpectedly massive, meaning apparently containing more stars than expected. In plain language, Webb kept finding galaxies that looked too successful too soon. One bright object can be a fluke. A whole class of them is harder to dismiss. That is when people began asking whether the problem was with the data, the measurements, or the basic rules inside the models that describe how early galaxies are supposed to grow. The CEERS survey added fuel to that fire. Some of its early results seemed to show galaxies in the early universe with masses so large that people wondered if the standard model of cosmology was in trouble. That standard model is the big framework scientists use to describe the universe on the largest scales, including dark matter, normal matter, and dark energy. It has passed many tests. So hearing that baby galaxies might challenge it was a serious claim. The issue was simple to say and hard to solve. If galaxies really built giant numbers of stars so quickly in the first few 100 million years, maybe either star formation was much faster than we thought, or some hidden effect was fooling us into overcounting the stars. And then came the first twist. A later NASA-backed analysis led by Katherine Chorowski at the University of Texas argued that at least some of those early galaxies were not as massive as they first seemed. Why? Because black holes can make galaxies look brighter than they really are. Gas falling toward a black hole heats up because of friction and shines strongly. If astronomers mistake some of that extra light for normal starlight, they can overestimate how many stars are there. In other words, some of the supposed giant early galaxies may have been wearing a disguise. They still looked bright in Webb, but the brightness did not all come from stars. That lowered the mass estimates and eased the biggest panic. So does that mean the mystery is over? Not even close. The same study said the early universe still seems to contain roughly twice as many massive galaxies as many models predicted, even after the most extreme cases were corrected. The standard model may not be broken, but it is not walking away untouched either. The crisis got smaller, not gone. The numbers still point to a universe that was unusually good at making bright, heavy systems very early. Maybe gas turned into stars more efficiently back then. Maybe dense early conditions made it harder for young stars to blow gas away, which would let even more stars form faster. Or maybe black holes and star formation were growing together in ways we are only beginning to understand. What would surprise you more right now, that the first result was too dramatic, or that the corrected result is still strange anyway? Drop your answer in the comments, tap like if you enjoy mysteries that get harder after the first explanation, and subscribe if you want the next clue when it appears, because the universe did not give Webb one problem. It gave Webb layers. Those layers get even stranger when we meet the objects called little red dots. Soon after Webb began real science work, astronomers started finding many tiny red sources in the early universe. They looked compact, bright, and oddly colored. At first, no one was sure what they were. Some scientists now think many of them are growing supermassive black holes wrapped inside dense clouds of gas and dust, and that gas can block or soften the usual signals astronomers expect to see, which makes these objects hard to classify. In a way, little red dots may be the missing actors behind some of the confusion. If a bright early object includes a black hole hidden in gas, it can mimic a young galaxy packed with stars even when the full story is more complicated. The clue comes from spectra. A spectrum is what you get when light is split into its component colors, so scientists can read chemical fingerprints and motions inside it. Several little red dots showed signs of very fast-moving hydrogen gas. That kind of speed is important because gas orbiting near a feeding black hole can move at huge velocities. Stars spread out through a normal galaxy do not usually create that same signature, so once Webb began taking not just pretty pictures, but detailed spectra, the case for black holes and at least some little red dots grew stronger. That helped explain part of the brightness puzzle, but it also opened a new door. If black holes were already active so early, then black hole growth itself may have begun much faster than expected. And this is where another observatory joins the story. NASA compared Webb results with data from the Chandra X-ray Observatory and found what some researchers called an X-ray dot. Its formal name is 3DHST-Aegis-12014, and it sits about 11.8 billion light years away. It shares many traits with little red dots, but unlike most of them, it also gives off X-rays. That matters because actively feeding black holes often shine in X-rays. The team suggested this object might be a transition stage, almost like catching one little red dot while it is changing. If true, it could show a black hole breaking through the gas that once hit it. Think of it as seeing the mask slip for the first time. Why does that matter for the bigger mystery about things that should not exist? Because now the problem is not just early galaxies. It is early galaxies, early hidden black holes, and maybe early black hole growth happening together. Webb may not be showing us one impossible class of object. It may be showing us a whole fast-moving ecosystem forming far sooner than expected. The oldest galaxies are not only turning on, some may already host black holes that are eating gas, pumping out light, and changing how we measure them. In the old mental picture, the early universe was a slow first draft. In the new picture, it may be a crowded workshop where stars, galaxies, and black holes all race to build themselves at once. Then came an even newer record, MOM-Z14. NASA announced this galaxy as a confirmed bright system from only about 280 million years after the Big Bang, pushing the observed universe even closer to cosmic dawn. Its redshift is 14.44, which is just the technical way of saying its light has been stretched enormously by the expansion of space. What matters in simple terms is this. Webb is now seeing a galaxy from a time so early that many older ideas treated that era as barely open for business, yet MOM-Z14 is not whispering, it is bright. NASA even noted that galaxies like this seem to be roughly 100 times more common than many pre-Webb theoretical studies had predicted. That is not a tiny adjustment, that is a very loud mismatch. Now listen to the chemical part, because this is one of the hardest pieces to ignore. Researchers studying MOM-Z14 reported unusually high nitrogen. Nitrogen is not something you expect in large amounts right away. Normally, heavier elements build up as stars live, burn, and die, enriching later generations. But MOM-Z14 appears so early that there should have been less time for that normal step-by-step buildup. Some scientists suggested that the earliest universe may have formed extremely massive stars, much larger than the stars we see around us today. Those giant stars could live fast, burn hard, and dump out unusual amounts of certain elements. If that idea is right, then the first stellar generation may not have been a smaller version of the modern universe. It may have been a very different kind of engine. JADES-GS-Z14-O added a similar shock from another direction. Follow-up work reported oxygen in this very distant galaxy. Oxygen is a heavy element too. You only get it after stars make it in their cores and then spread it out through events like stellar winds or explosions. So finding oxygen in a galaxy from such an early time is like finding signs of adolescence where you expected infancy. It means the place had already gone through enough star formation and chemical change to leave visible traces behind. Once again, what scientists expected was a simple young system. What they found was something that already looked processed, enriched, and more mature than its age should comfortably allow. Did you think the real surprise was just the size of these galaxies, or is the chemistry even stranger to you? Leave a comment with the one clue you find hardest to explain. Hit like if these details make the early universe feel less like a blank page and more like a crime scene, and subscribe for the next piece. Because the timeline keeps shrinking, Webb also found another class of surprise that many people missed because it sounds less flashy, but it may be just as important. Astronomers led by researchers from Cambridge reported an extremely early dead galaxy seen when the universe was only about 700 million years old. A dead or quenched galaxy is one that has mostly stopped making new stars. That means this system not only formed stars early, it formed them quickly, burned through the phase, and then shut down before the universe was even 1 billion years old. The team estimated that its main burst of star formation may have lasted only about 30 to 90 million years and then stopped roughly 10 to 20 million years before Webb saw it. That is not slow growth. That is a sprint followed by silence. Think about the order of events packed into that one finding. First, gas has to gather, then stars have to form in large numbers. Then something has to halt star formation either by using up the gas, heating it, or pushing it away. In the modern universe, we often see galaxies stop making stars much later, but here Webb may be showing a galaxy that lived fast and went quiet in cosmic childhood. It is almost like finding an abandoned factory in a town that was only built last month. You instantly know the pace of events was far more intense than expected. Even if that galaxy later started making stars again, the simple fact that such a shutdown was possible so early tells us the first era of galaxy life was more dramatic than our older models assumed. There is another ongoing clue in the background of all this, and it reaches even farther than one galaxy. Early space was filled with thick hydrogen gas that blocked certain kinds of light. Astronomers call the later clearing of that fog reionization. Webb was built partly to map when that clearing happened. Some of these early bright galaxies, including objects like JADES-GS-Z13-1 and MOM-Z14, seem to show that regions around them were already beginning to clear. That means strong sources of energetic light were active very early. Once again, the expectation was gradual change, but Webb keeps pointing toward pockets of early intensity, as if the first galaxies were not timid candles, but powerful lamps helping cut holes in the fog of the young universe sooner than many had expected. And this is no longer just a story about what happened long ago. It is a story that is changing right now. Every new Webb observing cycle adds more data, more spectra are being taken, more candidates are being confirmed or ruled out. Teams are arguing, checking each other, revising mass estimates, and testing fresh ideas. That is important because science is not strongest when it shouts. It is strongest when it survives being questioned from every angle. Some of the earliest dramatic claims have softened. Others have held up. New objects keep appearing that do not fit neatly into old categories. So the picture today is not that Webb proved everything wrong. The picture is that Webb opened a part of history we had modeled mostly from a distance, and reality is proving richer, noisier, and faster than expected. That is why you will hear two statements that sound like they clash, even though both are true. First, no, the universe has not been officially broken by James Webb. The standard model of cosmology still explains huge amounts of data and still stands. Second, yes, Webb has shown that some major details inside our story of early galaxy growth need real work. Those are not opposite ideas. They are the normal outcome of better tools. The skeleton of the big cosmic picture may remain while the flesh on those bones changes shape. Scientists may need better rules for how quickly gas made stars, how soon black holes grew, what the first stars were like, and how common bright compact systems really were in the first few 100 million years. Here's the pattern that keeps repeating, and this is the part that makes the whole mystery feel so sharp. Scientists expected tiny early galaxies. Webb found many bright ones. Scientists expected chemical immaturity. Webb found signs of oxygen and unusual nitrogen. Scientists expected black holes to appear, but not necessarily so hidden and so influential so soon. Webb found little red dots that may be exactly that. Scientists expected galaxies to spend their early life forming stars. Webb found one that may already have shut that process down. Each single case can be debated, but taken together they all push in the same direction. The first chapter of the universe seems more active, more crowded, and more efficient than many people expected. What do you think is really happening here? Are we catching rare cosmic weirdos, or did the early universe simply grow up much faster than we imagined? Tell me your guess in the comments. Press like if you love moments when real evidence forces a rewrite, and subscribe so you are here when the next Webb result changes the picture again. Because the next answers may come soon. The emotional power of this story comes from how personal the scale feels once you shrink it down. We are not just talking about distant dots, we are talking about the oldest structures that lead step by step to later galaxies, later stars, later planets, and eventually us. These ancient systems are part of our family history. They are not close family in any normal sense, but they sit near the root of the tree. When Webb finds galaxies that look more mature than expected, it is not just adding an odd fact to a chart. It is changing the opening pace of the story that eventually produces every star-filled sky, every heavy element in your body, and every world that may someday hold life. Some viewers hear news like this and wonder if it means danger, as if the universe is hiding monsters out there. But this is not that kind of mystery. These galaxies are not threatening Earth. Their light is ancient, stretched, and faint by the time it reaches us. The stakes are deeper than danger. The stakes are understanding. If galaxies and black holes formed earlier and faster, then the conditions for later cosmic structure may also have arrived sooner. That affects how we think about the growth of matter, the spread of heavy elements, and the long chain that leads from a hot young universe to worlds like ours. It tells us the cosmos may have become organized earlier than expected, and that changes what kinds of histories might be possible elsewhere. It also delivers a lesson science teaches again and again. Nature does not owe us simple timing. We build models from the best evidence we have, and those models can work beautifully until a better instrument lets us see what we were missing. That is not failure, that is progress. James Webb is not embarrassing astronomy. It is doing exactly what a great observatory should do. It is finding the places where our ideas are too neat. It is forcing experts to separate what they truly know from what they only assumed. And in a strange way, that makes the universe feel more alive. Not magical in the fake sense, but genuinely surprising, with history that resists being flattened into a clean and easy script. More help is coming too. Future Webb work will keep stacking up data, and NASA's Nancy Grace Roman Space Telescope is expected to widen the search dramatically by finding many more early galaxies across larger areas of sky. That matters because one of the best ways to solve a mystery like this is with bigger samples. Are these bright early systems rare exceptions, or are they common? Do little red dots represent one stage of black hole growth, or several different things mixed together? How often do we see early chemical enrichment? How early does reionization really begin in different regions? Right now we have stunning clues, but still not the full map. The next few years may turn these strange discoveries from shocking headlines into a new normal. And maybe that is the most beautiful part. For almost all of human history, the beginning of the universe was a wall Then it became a foggy horizon. Now, for the first time, it is turning into a place with weather, patterns, and characters. We can point to specific galaxies with names, ages, and odd behavior. We can argue about their chemistry. We can ask whether a hidden black hole is changing the light. We can test whether a dead galaxy really died young. The first few 100 million years are no longer just a dark zone filled with guesses. Webb is turning them into a living scene, and the scene it reveals is far stranger, far busier, and far more interesting than the old sketches suggested. And if you want to follow this mystery as it unfolds, subscribe, turn on notifications, and do not miss the next update. In the comments, tell me which clue bothers you most: the giant brightness, the early oxygen, the hidden black holes, or the dead galaxy that went quiet too soon. And if this story made you rethink the early universe, share it with someone who still thinks space is empty and simple. Thanks for watching. I'm glad you spent this time out here with me. See you in the next mystery.